Hello guys, and welcome back to another episode of chemistry. And of course, we are going to continue our study on benzene. All right, before we continue, know that this tutorial is brought to you by the O3 Schools JAMB CBT Practice app. All right, we'll tell you more about the app in a bit, but please let us see a question from the app. This is a 2010 question from JAMB, 2010 question number 43. All right, so it says here that benzene reacts with hydrogen in the presence of nickel catalyst at 180 degrees Celsius to give A, xylene, B, toluene, C, cyclopentane, D, cyclohexane. All right. So please, we'll come back to this class, come back to this question at the end of the class, not before, because we believe in giving you value. We believe that you should learn first before you start attacking questions. That makes what learning easier and more fun. All right. So please, do not forget to get your O3 School JAMB app. All right. The app has all you need to succeed in your exam. If you want to succeed and not succeed, please jump to Play Store immediately and download that application. All right. Stop wasting your time. It has all the past questions that you need for your exam, so you don't need to worry about going to buy past questions anywhere. What's more is that there are lecture notes on the app structured according to the JAMB syllabus. Some of you study without your JAMB syllabus, and that's a big no. All right. So please, you have to study according to what JAMB say you should study. So lecture notes are there, so you don't need to worry about going to buy textbook anywhere also. Then there's a wonderful feature called the question search feature, where you can search for questions according to topics and the question that JAMB has set from previous years. All right, on that topic will come out for you to answer. What's more important is the UTME mock challenge, a challenge that will conduct for all students that are writing JAMB for a particular year. Compete with your mates, get used to JAMB past questions, get used to JAMB likely exam questions, as well as what see your score release every Saturday. All right, that mock is every Saturday, of course. So once you have the app on your phone activated, you can participate in all of those mocks. All right, so please do not play and do not sleep on the application. Activation fee is just for a little token. Pay the sacrifice and activate immediately. So today we are seeing what the reactions that benzene undergoes. Reactions of benzene. In the previous class, what we saw was preparation of benzene, but today we are going to see reactions of benzene. All right, and of course, benzene undergoes what a number of reactions. All right, both substitution and addition reactions. Okay, so we do say that what they are favored mostly by substitution reactions, but they undergo. It's not say they do not undergo addition reaction, but they undergo reaction with a little bit of what difficulty. Okay, so they undergo addition with a little bit of what difficulty. Not that they do not undergo addition reactions at all. All right, so do not get that point what's mixed. Also, let us see some addition reactions. First of all, thought of benzene. Then we'll move further to oxidation reactions. All right. So let us see. Number one is catalytic hydrogenation. Okay, using either nickel, platinum, or palladium as catalysts. Okay, so this one of the addition reaction that benzene undergoes. All right, it's an addition reaction, catalytic hydrogenation, using nickel, platinum, palladium as catalyst. And what this gives to us, the product of this reaction is a cyclohexane. All right, the product of this reaction is cyclohexane. It is very, very important that you take note of this reaction. It's very, very popular, and it comes. In fact, you see this question repeated over several times in your JAMB past question. So please, you do not need to play with this reaction. So what happens is that benzene vapor reacts with hydrogen, all right, using any of these catalysts, either nickel, platinum, or palladium, and of course it now gives us this product. All right, so give in the presence of this catalyst to give cyclohexane. Okay, so let us see how that reaction runs. Okay, so if you have your benzene ring, okay, benzene, okay, then it reacts with what now? With hydrogen. It's catalytic hydrogenation. That is addition of hydrogen. All right. So if you react with hydrogen, okay, in the presence, okay, of a nickel catalyst, either nickel, platinum, or palladium, all right, it will give us our cyclohexane. This is our cyclohexane. Okay. All right, this is our cyclohexane. You can see that there's no double bond here. Okay, like this in this type. This is benzene. Okay, but without these bonds, okay, it is cyclohexane. If you want to draw cyclohexane out properly, this is how it will look like. This will be C. Okay, this will be C. This will be C. This will be C. All right. Then you now have here also C. Here C. This. Okay. Sorry. This way like this. Okay. So this is your last. Let me just put it this way. So this is a cyclohexane. All right. Then you have what? Your H here. 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 Your H here, your what? H here. So this is what? Cyclohexane, C6H12. All right. And as you can tell already, the reaction can the reaction is what? It happens in the presence of what? Of a nickel catalyst. Please, you must take note of that. Okay. So when hydrogen reacts to benzene vapor using what? A nickel catalyst, the product of that reaction is what? Is a cyclohexane. So this is our benzene ring. Okay, then this is what? Our hydrogen. Okay, and then this is what now? Our cyclohexane. Okay, so the temperature of this reaction is around 180 degrees to 200 degrees Celsius. Also, please take note of that. The temperature at which this reaction occurs is around what? 180 degrees Celsius to 200 degrees Celsius. Okay, so please, this is what the product of the reaction between what? Between benzene and what? And hydrogen. All right, in the presence of a nickel catalyst to give us what? Cyclohexane. It's an addition reaction. So please take note of the reaction. There's a reason why I'm stressing it. Please make sure you take note of it. So let us now see another reaction, another addition reaction that benzene undergoes. All right, and that one is called halogenation. Halogenation in the presence of sunlight. Halogenation in the presence of sunlight. So let us see that. Halogenation this time, not substitution. This is addition reaction number 2. Okay, so number 2 is what? Halogenation. Okay, in the presence of sunlight. Okay, so it also undergoes what? Halogenation in the presence of what? Of sunlight. So halogenation means what? That a benzene ring is reacting with what? With what? With an halogen. Okay, either chlorine or bromine. All right, as the case may be. All right, so the process of this reaction is very easy. Let us see what happens. So I have our benzene ring. Okay, our benzene ring. All right, then it reacts with what? With chlorine, Cl2. Okay, let us write a balance equation. So in the presence of what now? In the presence of sunlight, that is what? UV. Then what it gives to us is what? This. We're going to have this. All right. All right, then I'm going to have this. Then I'm going to have what? This. Then I'm going to have this. Then I'm going to have, I'm going to have what? This. All right, so this is what it gives to us. But in this case, I'm going to have what? Chlorine here, chlorine here, chlorine here, chlorine here, chlorine here, chlorine here. All right, so what we have, we're going to have 6 molecules, okay, of what? 6 atoms rather of chlorine in each. We're going to have what? 1 atom of chlorine in each of what? The carbon atoms. Okay, you're not going to have 2, just like we saw in what? In hydrogenation. All right, to now give us cyclohexane. All right, okay, so in this case here, we're going to have what now? 1 atom of chlorine in each of the carbon atoms. All right, so this is the product of what? Of the halogenation reaction between what? Benzene and what? And chlorine in the presence of sunlight. This compound will be called 1. Okay, because if you number 1, 2, 3, 4, 5, 6. Okay, if you number the carbon atoms, 1, 2, 3, 4, 5, 6. This one will be what now? 1, 2, 3, 4, 5, 6. Hexachloro. Okay, hexachloro what now? Hexane. Hexachlorohexane. All right, so this we call 1, 2, 3, 4, 5, 6 hexachlorohexane. Okay, this is the product, okay, that it gives to us. You can also call this product, so putting 1, 2, 3, 4, 5, 6, 7, 8, you can say what? Hexachlorocyclohexane. All right, so you can also call it hexachlorocyclohexane or 1, 2, 3, 4, 5, 6 hexachlorohexane. Okay, so please take note of what? Of that. So this is a product of what? Of the halogenation reaction between what? Benzene, what? And an halogen to give in the presence of UV or in the presence of sunlight. Okay, so please take note of what? Of that addition reaction. So if you do not see that first addition reaction, be very sure that what? In the exam you either see the second addition reactions. Please ensure that you just take your time to understand the reaction. Okay, now let us now go to oxidation reactions that benzene undergoes. Okay, oxidation reactions that benzene undergoes. All right, and the first one, of course, is catalytic oxidation of what? Of benzene. Catalytic oxidation of benzene. We're looking at oxidation reactions now. Oxidation of benzene. Okay, so one we have catalytic oxidation. Catalytic oxidation of what? Of benzene. Okay, so this means that what benzene reacts with what? With oxygen. Okay, under what? The presence of a catalyst. All right, so I'm going to see the catalyst. Catalyst is what? Vanadium 205. So the reaction condition is V2O5 as catalyst at temperature of 450 degrees Celsius. All right, this is what the reaction condition, okay, for catalytic oxidation of benzene. So the first product it gives to us is maleic anhydride. Maleic anhydride. Okay, but on further reaction of this maleic anhydride with H2O, which is what? Water, it now gives us what we call maleic acid. Okay, then now gives us maleic acid. This maleic acid is also called 2-butene 1,4 dicarboxylic acid. All right, so please take note of that. This maleic acid is also called 2-butene 1,4 dicarboxylic acid. You must take note of what? Of that. All right, so now let us see the reaction. So first of all, I'm going to just write the full equation reaction. All right, so I'm going to have what? Your benzene. Okay, don't mind my weary benzene. Okay, this is your benzene now. That is benzene. Okay, then it reacts with what? With 9 molecules of what? Of oxygen. Okay, take note of that. Then of course, the reaction condition is what? Vanadium oxide, that V2O5, or vanadium, call this vanadium pentoxide. Okay, and temperature is what? 450 degrees Celsius. All right, so we say this gives us a maleic anhydride. This maleic anhydride. Okay, all right, then C. Then here, double bonded to O. Please take note of that. Double bonded to oxygen. Then here, you now have O. Okay, yeah, double bonded to O. Okay, so please, you must take note of what? Of this structure. All right, I hope I'm not drawing this out of the board. All right, if I am, let me reduce this. Okay, so this is actually what? C. And then this double bonded to what? To O. All right, this is what? Your maleic what? Anhydride. This is called maleic anhydride. All right, then of course there are other what? Product of the reaction. That is what? Carbon dioxide and water. I'm going to have what? 4CO2 then plus what? 4H2O. This is what? The reaction what? Of what? Of benzene with what? Oxygen. Okay, it first gives us what? Maleic anhydride. This is maleic anhydride. All right, then on further reaction of what? This maleic anhydride with what? With water, it now gives us this what? Maleic acid, which is 2-butene 1,4 dicarboxylic acid. Let us see that reaction. All right, remember it's still catalytic oxidation of the first oxidation reaction of benzene that we're looking at. Catalytic oxidation of what? Of benzene. All right, so when this reacts with what? With water, that is C double to O. Sorry, then I'm going to have C double bonded to what? To O. All right, then I have what? Our O. Then I have our this. Then of course plus what now? H2O. All right, this now gives us what now? CH, C double bonded to O, OH. Then CH, this double bonded to what? OH. So this one is now called what? Our maleic acid. Okay, this is what our what? Maleic acid, or our what? 2-butene. If you number 1, 2, 3, 4. Okay, the carboxylic acid group, you can see that they are in position 1 and 4. Okay, so we now call this what? 2-butene 1,4 dicarboxylic acid. Okay, very simple as ABC. All right, so this is what the oxidation reaction of what? Of benzene, the catalytic oxidation of what? of what? Of benzene. Okay, catalytic oxidation of benzene. First to maleic anhydride, then on further reaction of water to what? To maleic acid, or 2-butene-1,4-dicarboxylic acid. Just calm your mind down. Very easy. All right. So just write the reaction yourself. Write it again without looking at the book. Before you know, you have gotten it. As simple as ABC. All right. So please do not forget to like this video. Liking this video will make other students easily find this video. All right. Abi, you know one made a pass. So please do like the video. Or if you have not subscribed to this channel, you are doing yourself, because subscription will send notification to your phone whenever we release a new episode. It is free to subscribe to the channel. So please make sure what you click on that red subscribe button if you have not done so before. All right. And of course, if you have not, if you are not sharing these videos to your friends, to your loved ones, to your class groups, everywhere, then you are wicked. Okay. Please. We do not have wicked people in this army. Okay, in this O3 schools army where I am the commander, okay, of the soldiers, we are very, very generous. Please keep sharing those videos to all your social media platforms, Facebook, to your WhatsApp, or to your Instagram. Keep sharing. All right, so let us continue. Let us see another oxidation reaction of benzene. So this time we look at what? Combustion. Combustion. Okay, so combustion. All right, so benzene also reacts with what? With oxygen. Okay, all right, in the presence of what? Of flame. All right, to give us a number of what? Of product. Let us see that what? Combustion reaction. So this is your benzene. Okay, then reacting with what? With oxygen. Let me just write a balanced equation. Plus 15O2. 15O2. All right, in the presence of what? Of flame. All right, then the product of the reaction gives us what? 12CO2 plus 6H2O plus what? Heat. Okay, so heat is what? It's also what? Released. Okay, so please, this is the complete what? Reaction of what? Combustion of benzene with what? With oxygen. Okay, so when benzene burns in air, okay, what it gives to us is what? It gives us this product, carbon dioxide, water, and what? And heat. Heat is also a product of what? Of that what? Reaction. You must take note of what? Of that. Okay, heat is a product of that reaction. So let us also see another what? Oxidation reaction, which is ozonolysis. Ozonolysis. All right, so benzene also what? Undergoes what? Ozonolysis. Let us see ozonolysis. So in this case, it is what? Reacting with not oxygen in this time, but it's what? It's reacting with what? With ozone. All right. So of course, let's now see ozonolysis. Okay. So now, benzene will react with ozone. This is our benzene ring. Okay. It will react with what? With ozone, which is what? O3. Okay. Okay, so it reacts what? With benzene, with ozone. That's O3. The balance, let me just write a balance equation once and for all. So it reacts with what? With ozone, O3. Then what it gives to us is C6H6O9. Then, which is this C6H6O9 is called benzene triozonide. Okay, this C6H6O9 is called benzene triozonide. It's called benzene triozonide. But on further reaction of this benzene triozonide with what? Water and what? Zinc. Okay, it now gives us what? What we call glyoxal. Okay, it gives us what? Glyoxal. Please take note of what? Of that. All right, so let's go. So on further reaction with what? With H2O and what? And zinc. Okay, zinc dust. It gives us what now? Glyoxal. That is C2H2O2 then plus what? Zinc oxide. Okay, this is what it gives to us. All right, so it's actually what? 3 molecules. Okay, 3 molecules of what? Of C2H2O6. Let's take note of what? Of that reaction. All right, that's called glyoxal. This is called glyoxal. Okay, it is what? The simplest dialdehyde. Okay, it's the simplest of dialdehyde. Okay, the structure of glyoxal, something like this. Okay, you have C. You have C. Okay, this one double to O. Okay, let me just put the double bond somewhere here. Double to O. Then this one double to O. Then you have what? H. Then you have what? H. Okay, to complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is the simplest what? Dialdehyde. That is called glyoxal. Okay, so please take note of this reaction also, and this is of course zinc oxide. Zinc oxide. Okay, this is benzene triozonide. Okay, so this is the first first product of the reaction, benzene triosonide, and then of course on further reaction with zinc, dust, and water, it gives us what? Glyoxal and what? And zinc oxide. So please, you must take note of this reaction. Now, last reaction I'm going to be looking at is oxidation of side chain. Okay, oxidation of side chain. This oxidation of side chain, let us see oxidation of side chain, is used as an identification test for alkyl benzenes. Okay, it's used as an identification test for alkyl benzenes. Let us see. That's number 4. That's IV now. Oxidation of side chains. Okay, we say this oxidation of side chains is used as an identification test. Identification test for what now? For alkyl benzene. Okay, so what do we mean by an alkyl benzene? A benzene ring that has what? An alkyl group attached. Okay, for example, this is an alkyl benzene. It's a benzene ring. Okay, let's say here this was CH3. Okay, of course, you know that this one has a name, has a parent name. This is what? Toluene. Okay, we have seen when we see benzene, when we saw benzene derivative, this is what toluene. If it is C2H5 here, okay, C2H5, it is called what now? It does not have a parent name, but of course, it's called ethyl benzene, because this is what? An alkyl group, which is what called ethyl. So that would be called ethyl benzene. What about if it was, I'm just trying to reverse a benzene derivative so you can go back and listen to it. So if first of all you have CH3 here, then we now have what? CH3 here also. Okay, so this is called what now? Xylene. Okay, it's called xylene. Okay, but this is 1, 2, 3, 4. So this is called p-xylene, because what? The methyl groups, okay, all the alkyl groups are in position 1 and 4. All the groups, all right, attached to the benzene are in position 1 and 4. Okay, if they were in position 1 and 2, for example, let's say this was here, CH3. What do we call this one? O-xylene. That's all ortho-xylene, O-R-T-O. This one means para. Okay, if they're in position 1 and 3, okay, let's say yes, was CH3. Okay, we'll call this one a meta-xylene. Okay, and so on and so forth. So it's as easy as ABC. Okay, so identification of, oxidation of side chains. So what actually gets oxidized, okay, is this side chain, these alkyl groups. Okay, it's not the benzene itself. The benzene does not react with what? With K2CR2O7. They do not react with what? K2CR2O7 or KMNO4. All right, so please, you must take note of that. They do not react at all with it. Okay, what they react to, what they oxidize is what? Is the side chain. So they oxidize this side chains to what? To carboxylic acid what groups. Okay, they oxidize this side chain to carboxylic acid. It may be either what? Carboxylic acid or dicarboxylic acid, depending on how many side chains are present. Okay, for example, here, if this is a xylene, now we have 2 methyl groups attached to what? To the benzene ring. So that will give us a dicarboxylic acid. Let us quickly see the reaction and we'll take questions and we're done with this class. All right, since we have been spending so much time here. So let's go. So oxidation of what? Of side chains, which is an identification test for alkyl benzene. So we have what? Our benzene ring. All right. Okay, then we have what? Let's say here is what is CH3. Okay, so since we have CH3, we already know that what? Okay, so this is our benzene ring. Let us do everything properly. Okay, so this is what? Our benzene ring attaching itself to a what? To a methyl group. Obviously, we know that this has what? A parent name, which is what? Toluene. Okay, so toluene will react with what now? With oxygen. Okay, it is what? It is oxidation. So it's what? It reacts with oxygen. All right, so now let us say it now reacts with, let me draw that a full and balanced equation for this reaction. So it reacts with what? 3 molecules of what? Of oxygen. All right, and the condition for the reaction, of course, we are passing it through what? KMNO4, alkaline KMNO4. All right, that's why I see this OH group here. All right, so if we are passing it through alkaline KMNO4, then this gets what? Oxidized. The side chain is one that gets oxidized, not the benzene ring. Okay, so the side chain gets oxidized. We'll still have our benzene ring at the end of the reaction. Okay, we'll still have our benzene ring. All right, but this side chain will get oxidized to the what? To the carboxylic acid. All right, so what we now have here, instead of CH3 now, what we have here is what? This. Our benzene ring staying intact. We are going to have our COOH, of course, plus H2O. All right, so this will be the product of our reaction. Very easy. So let's say, for example, it's an ethyl benzene. This is our toluene. Then this is what now? What is this one called? All right, we did what? That's how we did what benzene derivative. If you have not watched that class, go back and watch it. This is called benzoic acid. Okay, this is called benzoic acid. All right, so remember, you can see draw it like this. Instead of COH here, you can draw this. Okay, OH. Okay, at the top here. So you see the same. All right, so now let us see. What about it's an ethyl benzene? Okay, so if it's an ethyl benzene, let me take this off because of space. It's an ethyl benzene. Okay. All right, it's a benzene ring. Then, of course, if it's an ethyl benzene, that means I'm going to have C2H5 or CH2CH3 group attached to the benzene ring. All right, so this also what gets what oxidized. Okay, it's this side chain that gets oxidized to the what, to the carboxylic acid. All right, so please must take note of that. So it gets oxidized to what? Let me draw that to what, a balanced what reaction. 6 what atoms of what, of oxygen. The same condition. All right, KMNO4 then OH minus. All right, and then this side chain gets oxidized to what, to a carboxylic what, acid. So I'm going to have what, this. Okay, so I'm going to have COOH. All right, then of course we also have other products of reaction, which is what, CO2 and what, and H2O. CO2 plus 2H2O. Okay, so this is the balanced reaction for what, for this reaction. Okay, for what, for ethyl benzene. What if it is not what, an ethyl benzene? Let's say it's a, what is a xylene. A xylene is a benzene that has attached to itself 2 methyl groups. Okay, so it may be para-benzene or meta-benzene or ortho-benzene. Okay, but it is the positions, okay, that what, that those groups are attached, that what the carboxylic acid what we form on. Okay, so please, you must take note of that also. So it's very easy. So let us do that. So let us quickly see the last reaction. Let me take it up here because of space. This is the last reaction we're considering, and we're done with this class. Let's go over that. So we now have this, a benzene ring. All right. Then of course we have what, CH3 here. Here to CH3. Okay. So these methyl groups are in position what, 1, 2, 3, 4. Position 1 and 4 respectively. So obviously this is what now, a peak xylene. Okay, it is xylene, but it's a para-xylene because the groups are attached at position 1 and 4. All right, if they are attached at position 1 and 2, they are called ortho-xylene. Okay, if that's what, 1 and 3, they are called what, meta-xylene. So this now react, of course, with what, with oxygen. This is a balanced reaction. We do just what, 1 molecule. Then of course you are going to have what, the same condition, KMNO4 OH minus. All right, so now the carboxylic acid that will be formed, the carboxylic acid group that will be formed at position 1 and position 4 or the benzene ring. Remember, nothing happens to our benzene ring, so I'm going to have what, our benzene ring, COOH, and then here also COOH at this position. Then of course, other products is what, is water. This one is called what? This compound is called what? 1, 4. Okay, let me just say it's called benzene. Start with benzene ring, benzene 1,4 dicarboxylic acid. Okay, very simple as ABC. All right, so this is what the reaction that benzene undergoes. Okay, so now I don't quickly going to what, head over to past questions and then what, to take questions, and we are done with this class. So this is a 2010 question number 43. We say benzene reacts with hydrogen in the presence of nickel catalyst at 180 degrees Celsius to give, obviously, is what? Is option C, which is what, cyclopentane, sorry, option D, cyclohexane. We have seen that reaction from the beginning. Okay, so let us continue. 2008 question 48. It is being displayed on your screen right now. The product obtained when a mixture of benzene vapor and hydrogen are passed over a nickel catalyst at 180 degrees Celsius is A, obviously, is what, cyclohexane. So the correct answer there is option A. There's no need to beat around the bush. So you can see the question repeated again in another form. Then 2001 number 39. Catalytic hydrogenation of benzene. Catalytic hydrogenation of benzene produces what? Obviously, is what? Cyclohexane, also option C. You see it repeated in another form. So later you say JAMB does not repeat past question. So please go and get your application and stop wasting your time. All right. So please, we are going to continue our study in the next class. We're going to look at the uses of benzene, and then we are done with this class. So do not forget to like this video. Do not forget to subscribe. Do not forget to keep sharing, and do not forget to activate your application. Thank you for watching. My name remains Master T, your Grand Commander. I will see you in the next episode.